Jai Hind students, my name is Ayushi, Assistant Professor from IT Department, AKGEC. Today I am here to start a new topic, that is sorting, and today we are going to start with the first sorting technique, that is bubble sort. Before discussing what is bubble sort, it is very important for us to know what is sorting. What do you know, what do you understand about sorting? Whenever I am taking term sorting, what it is going to click in your mind? Sorting is to arrange. Sorting means is to arrange something, is to arrange elements, or to arrange elements in certain specific order. In order to arrange elements in a specific order, there can be only two orders: ascending order and descending order. But in C programming language, whenever there is going to be a discussion about sorting, it is always be for ascending order, that is increasing order. So what is a sorting technique? A sorting technique is a process of rearranging all the elements of an array in a particular order, that is going to be ascending order only. In ascending order, that means first we have to place smallest element of the array at the beginning, then subsequently we will move towards the end by putting the greater values as comparison to the predecessor value. There are many different types of sorting techniques we can perform with the help of C language, but in our curriculum in first year syllabus, we have to know initially only 3 sorting techniques. First is bubble sort, second is selection sort, and third is insertion sort. To begin with, we will start with the simplest of simplest sorting technique, that is bubble sort. What is a bubble sort? It is a sorting algorithm that compares two adjacent elements and swaps them only when first element is greater than the second element, because as per the ascending order, the first element out of the two elements, first element will always be the smaller, or will be of smaller value as compared to the second value. So swapping is going to happen only when the first value is greater than the second value. And this process of swapping in comparison, first we have to compare two subsequent adjacent elements, and we have to swap these two elements every time we encounter a greater element at the first position and smaller at the second position throughout the list, by comparing adjacent elements and swap them if they are in the wrong order. Wrong order is in first element. If first element is greater in comparison to the second element, then it is going to be considered as the wrong order. And this process continues until no swaps are needed, indicates that the entire list is sorted by now. Only then we will encounter the situation where no swapping is needed. But the drawback for using this bubble sort is that it is not suitable for larger data sets, or the array that is having huge number of values. So this algorithm is not suitable, does not work efficiently for large data sets. Then what is the working of bubble sort? How we are going to perform bubble sort? In the earlier slide, I have given just an overview about that. So before starting the theoretic block representation or the logical part, programming part, it is very important for us to understand step-by-step description of how we are going to perform the bubble sort. The first very thing is, first we have to take an array, one-dimensional array. In this subject, in this PPS sorting technique, we are applying only on one-dimensional array. So that for that, first we have to initialize and declare a one-dimensional array either at runtime or at compile time. Then sorting is going to happen. First, First, we will compare starting from the very first element of the array. In the first pass, we are going to refer each round of comparison and swapping as one round, or we can say pass. So we sort the array using multiple passes. They are going 5 elements in array. There are going to be n number of 5 number of we are going to find in the description that are going to follow. How many passes are going to be taken place in if we are taking 5 number of elements. So after the first pass, whenever after doing comparison and swapping multiple times, when the first pass has been completed, what output we got? We are going to have the maximum element goes to the end. If I am saying that a sorting is equals to ascending order here in C language, then that means the biggest value or the largest value is going to be placed at the last of the array, at the last position of the array. Because in ascending order, the highest value or the maximum value is placed at the end of the list, at the end of the list of the array. So what is the correct position of the maximum array? When we are comparing the first element out of 2 adjacent elements, when we are comparing 2 elements, if the first value is greater than the second value, then by this comparison, the values will get interchanged or swapped. And when this process is applied repeatedly, then what will be the outcome? The maximum value of out of all the elements of the array will get positioned at the last index value of the array. And in every pass, we process only those elements that have already moved to correct position. Okay. After k passes, the largest k element must have been moved to the last k position. The largest value is going to be placed at the last k position. And in each pass, we are going to consider remaining elements and compare all adjacent elements and swap only if the larger element is placed before a smaller element. And whenever after keep doing this repeatedly, we get the largest among all the elements at its correct position. Every pass will give the maximum value in the remaining lot get placed to the last index. So we are going to learn this particular sorting technique with the help of a description, with the help of an example. In this particular example, we are taking 5 elements. So value of n is here what? 5. N is equals to 5. And the index value of all these elements are going to be, this is 0, 1, 2, 3 and 4. This is A0, this is A1, A2, A3 and A4. And these are the 5 elements over which we are going to perform a sorting technique, especially bubble sort. So as I have told you, how we are going to perform this sorting technique? By comparing 2 adjacent elements starting from this index 0. First 2 elements are going to be A0 and A1. Suppose value of I is equals to what? 0. So we are going to compare AI with AI plus 1. We have to check whether AI is greater than AI plus 1. We have to perform this comparison every time before swapping. If this condition is true, only then we will swap these 2 values. So according to that particular condition, AI, that means A0 is greater than AI plus 1, 0 plus 1. A0 is greater than A1, yes or no? first we are going to compare these two values. Tell me whether these two values A0 is greater than A1. No. That means value will remain same, 25, 26, 16, 18 and 15. After comparing first two values, then we will compare next two values. For I equals to, this is I equals to 0 and now this is I equals to 1. AI is greater than AI plus 1. Yes, that means swapping is going to happen. So, what will be the resultant array? 25, 16, 26, 18, 15. Why that so? Because these two values after comparison, A1 is greater than A2. That's why we have swapped these two values. Then, next two values will get compared. Here, I is equals to what? I is equals to 2. AI is greater than AI plus 1. Yes, 26 is greater than 18. That means one more time swapping is going to take place. 18, 26 and 15. So, here I is equals to what? 3. One more time swapping will comparison will take place for I equals to 3, A3 and between A4. How we are going to take A4? Because I is what? 3, A3, that's why. And why A4? Because AI plus 1 will give us A4, 4I equals to 3. So, after comparison, AI is greater than AI plus 1. Yes, AI is greater than AI plus 1. So, one more time swapping will take place, 25, 16, 18, 15 and 26. Now, tell me, out of all the elements of array, what was the maximum value? What was the maximum value? The maximum value was 26, which is now placed at its correct position. हमेशा लार्जेस्ट वैल्यू ऑफ एरे कहाँ आनी चाहिए? सॉर्टेड ऑर्डर में, असेंडिंग ऑर्डर में अगर हम अरेंज करें, दैट शुड ऑलवेज बी प्लेस्ड एट द एंड ऑफ द एरे. दैट व्हाट हैपेंड नाउ. And this particular phase, the collection of these iterations, these 4-5 iterations, we are going to refer as pass 1. This is what? Pass 1. After pass 1, out of 5 elements, one element got placed at its correct position, that is the maximum value. Now, out of remaining 4 elements, we have to, for these 4 elements, we have to repeat the same process. Now, again, first 2 elements got compared, 25 and 16 when compared, 25 is greater than 16. Yes or no? Yes. Then that means one more time what we have to do? We have to perform swapping. Then array will be 16, 25, 18, 15 and 26. Later on, again we will apply the same sorting technique, same comparison. AI is greater than AI plus 1, yes. Then one more time swapping will take place. 18 and 25 will get swapped. So, array will look like 18 here and 25 there. Remaining elements will remain same. Now, comparison will take place for these two adjacent values, next two adjacent values. AI is greater than AI plus 1, yes or no? Yes. AI is 25 and AI plus 1 is 15. After receiving this condition as true, we will swap these two values also. So, the result will be 16, 18, 15 and 25 will get interchanged. So, value will be 15 here and 25 there. Then next two elements will get swapped, will get checked. 25 is greater than 26. AI is greater than AI plus 1. No. So, there is no need to perform swapping, and our entire array has been covered by now. So if 26 got placed at the last position after first pass, but and after the end of the second pass, we have received second largest value also to be placed at its correct position. Correct? This is how our array, sorted array, looks like after second pass. After second pass. So this is pass 1 and this is pass 2. By now, in both these passes, number of how many comparisons we have done in every pass? First, second, third, fourth. 4 comparison in first pass. In second pass, 1, 2, 3, 4. Also here in pass 2 also we are performing, we have done 4 comparisons. By now we have received how many elements? How many comparisons in each pass? 4 pass. So our array looks like this. After this, we have encountered that there still need to perform more swapping. So after second pass, our resultant array was this: 16, 18, 15, 25 and 26. This was our array, resultant array after second pass. After second pass, first 2 elements are this: ai and ai plus 1, that is 16 will be get compared with 18. Now tell me whether ai is greater than ai plus 1? No. If no, that means there is no need to interchange or to perform swapping further. Now next 2 elements, next 2 adjacent elements will get compared with the same condition. ai is greater than ai plus 1. True or false? 18 is greater than 15. Yes. That means after this comparison, swapping will performed. 15 will get interchanged with 18. That's how our array will look like. Next 2 elements will get interchanged. ai is greater than ai plus 1 here. 18 is greater than 25. No. That means this time there is going to happen no swapping. Swapping is always conditional. It is not mandatory that after each and every comparison we have to swap. No. If there is no need to swap, if ai is smaller than ai plus 1, if ai is not greater than ai plus 1, then there will be no swapping. Next 2 elements will get swapped. Now tell me whether there is need to swap these 2 elements. No, because ai is here not greater than ai plus 1. So after 4th comparison, that's how our array will look like. And by the time we have performed this comparison, all the elements of our array has been sorted? No. Only maximum value, second largest value and third largest value of the array has been positioned, has been placed to their correct place. So 18, 25 and 26, these are the last 3 maximum values of the array, of the entire array, and the remaining unsorted part is only this 16 and 15. So this is our pass 3. This is our third pass. जिसमें कितने comparison गए हैं? 1, 2, 3, 4. By now, in each and every pass that we have performed, every time 4 comparisons, or we can say 4 iterations of comparison has been done. That is consistent, that is uniform. Now one more pass is going to begin, because till now we have our entire array is not sorted. So first 2 elements will get compared whether ai is greater than ai plus 1. Yes, if ai is greater than ai plus 1, then we have to swap. Then 15 and 16 will get interchanged and the remaining array will be as it is. Now next 2 elements will get compared whether ai is greater than ai plus 1. No, that means no swapping. Array will remain same. Then next 2 elements 18 and 25 will get compared. Whether ai is greater than ai plus 1. No, that means this time also there is going to take not going to happen any swapping. Then for the last time we are comparing, because only last two elements of array are remaining. 25 is compared with 26. 25 is ai and 26 is ai plus 1. Next element, how we are going to switch or to jump to the next element? By using ai plus 1. So 25 is greater than ai plus 1. 25 is greater than ai plus 1. Yes. No. 25 is not greater than ai plus 1. So there is no swapping. There will be no swapping. Array will be same. So this is our resultant array. This is how our array looks like after 4th pass. And if we give a quick review or quick read to this array, 15, 16, 18, 25, 26. What we have encountered after 4th pass? After 4th pass, what we have encountered, that each and every element of the array is placed to its correct position according to the ascending order. If we want to sort the given array 25, 26, 16, 18 and 25 in ascending order, then this is the correct order. 15, 16, 18, 25, 26. Yes or no? By the end of the 3rd pass, for last 3 elements were at their correct position. And by the end of the 4th pass, what we have encountered, that all 5 elements are at their correct position. Because why so? In the last pass, we have only last 3 elements at their correct position. And at the end of the 4th pass, we have encountered all 5. Why so? Because if we are having 5 elements and we have positioned 4 out of them in their correct position, so by default 5th element will be placed at its correct position also. By default, अगर हम 5 में से 4 elements को sort कर चुके हैं, अपनी सही जगह रख चुके हैं, तो हमें 5th एलिमेंट के लिए अलग से प्रोसेस रिपीट करने की जरूरत नहीं है, क्योंकि बाय डिफॉल्ट 4 अगर करेक्ट पोजीशन पे चले गए हैं तो 5th ऑटोमेटिकली बाय डिफॉल्ट अपने सही लोकेशन पर पहुंच गया है होगा. ऑलराइट, दिस इज हाउ बबल सॉर्ट वर्क्स. And for 5 elements, for all these 5 elements, if we are having n is equals to 5, how many passes we have done? How many passes we have performed? Only 4. So we came to know, if we are having n elements, then there is need to run the logic of comparison and swapping for only n minus 1 passes. For n elements, how many passes? N minus 1 passes. And for in each pass, हर एक पास में कितने comparison हो रहे हैं? 1, 2, 3, 4. 4 comparison. 1, 2, 3, 4 comparison. All right. So with the help of these theoretical description, I am going to discuss the logic, programming logic here also. So I am discussing here only the logical part. I am not going to discuss how we are going to take an array, what different variables we are going to take. I am just discussing here the logical part only, the sorting part. I am assuming that you have entered, declared the array, entered all the elements in the array. So to begin with, first loop, we have to take two loops. First, outer loop is for number of passes. For n elements, how many passes we are going to take? N minus 1. So I am going to take a loop I to begin it with 0. So if I am beginning the I counter with 0 and there are n number of elements, so how many up to what value I am going to run this particular loop? अगर I की value 0 से begin हो रही है तो 0, 1, 2, 3, 4 times, only 4 times, sorry, 4 times we have to run the loop for number of passes, क्योंकि पांच elements के लिए हमें passes कितने चाहिए? 4, according to the example also. So I am going to write here n minus 1 and a loop will get updated with the increment value. So first, this loop is for what? This loop is for number of passes. And now we are going to write an inner loop also. This inner loop is for number of comparisons within a pass. Okay? तो ये हम डिस्कस कर चुके हैं कि कितने n नंबर ऑफ एलिमेंट्स के लिए n माइनस 1 पासेस होंगे और हर एक पास में कितने कंपैरिजन होंगे? 4. Not every time, but if we are taking n is equals to what? 5. तो number of passes भी कितने होंगे? n minus 1. So this is how our inner loop look like. For that we are taking a counter variable j. J is going to begin with 0 also here. And j will also be run up to n minus 1 value. J will increment it. And within this loop, within this nested loop, what I am going to write? I am going to write the logic of comparison. What we are comparing? We are checking that whether, suppose we are taking an array of, we have declared earlier an array of name A. For that I am going to compare value of A0 to begin with. A0 with A1. That is how we are going to receive with the value of j. We are going to take whether if aj is greater than aj plus 1, if aj is greater than aj plus 1, if a0 is greater than a plus 1, then we will perform the swapping. Suppose not in this particular example, but in another example, or for value of I, j, if j is equals to what? 1, then it will get compared with j plus 1, a2. So here a1 is greater than a2. Yes. So what will happen? We will take a variable temp. First we will swap interchange, we will swap, or we will write value of aj into temp variable. Then in aj we are going to write value of aj plus 1, and after that we are going to write or to insert value of temp in aj plus 1. That is what the logic of swapping. This is the closure of conditional statement, and this is going to happen for n minus 1 number of times. N minus 1 number of times. Then this is the closure of if loop, this is the closure of J loop, and this is the closure of I loop, outer loop. So this is how this is what our logic look like. But there is a catch. If you have written, you have also going with the flow of my discussion in the earlier two passes, in pass 1 and pass 2, when you got to rewind this video, you will encounter that after first pass we have received 26 at its correct position. In second pass we have received 25 and 26 at their correct position, both the largest and the second largest element at their position. So is that there was need to comparison 25 to 26 one more time? No. In the third pass, 18 is after two comparison, first comparison, second comparison. Third element 18, third largest element 18 is at its correct position, but even then we have compared it with its subsequent successive elements. 18 will get compared with the second last, and second last element will get compared to the largest element. So here these two iterations, these two comparisons are of waste. In the second pass, last comparison was unnecessary. In the third pass, these two comparisons are unnecessary because हमें तो हमारा sorted array last three elements जो हैं वो हमें इसी कंपैरिजन के बाद मिल गए. लास्ट थ्री एरेज तो एज इट इज है, देखिए आप लास्ट थ्री एरेज तो एज इट इज कॉपी हो रहे हैं, तो लास्ट टू कंपैरिजन हमारे वेस्ट थे. इन द फोर्थ पास अगर जैसे आप चेक करेंगे कि ओनली आफ्टर फर्स्ट कंपैरिजन के बाद ही हमारा पूरा एरे क्या हो चुका था, सॉर्ट. 15, 16, 18, 25, 26 ये 4 एरेज जो हैं, लास्ट 4 एरेज एज इट इज हमें कॉपी लग रहे हैं. तो ये स्टेप्स जो थे ये अननेसेसरीली थे, अनसॉलिसिटेड थे, हम चाहे तो इन्हें अवॉइड कर सकते थे. दिस इज द करेक्ट लॉजिक ऑफ बबल सॉर्ट, बट वी कैन मेक इट मोर एफिशिएंट, वी कैन मेक दिस लॉजिक मोर एफिशिएंट इफ आई विल राइट हियर n-1 minus I. So फॉर वैल्यू ऑफ आई कितने नंबर ऑफ टाइम्स लूप चलेगा, 0 से n-1 - 0, यानी लेस देन n-1 टाइम, n-2 तक चलेगा, यानी ओनली कितने कंपैरिजन होंगे, 4. ठीक है, 0, 1, 2, 3 कितने हो गए टोटल, हमारे कितने कंपैरिजन हो गए, 4 कंपैरिजन हो गए. जब i की वैल्यू क्या हो जाएगी, 1, when I will get updated to 1, then j will run from 0 to n is what, 5 minus 1 4, 4 minus I 1 3. तो 0 1 2 3 कितने टाइम्स चला, लास्ट टाइम कितना चला, 3, और अब कितने टाइम्स चलेगा, 0 1 2 एंड 3, क्योंकि लेस देन 4 चलना है हमें. ठीक है, ऐसे जब पास 4 पे आएगा तो कितने नंबर ऑफ टाइम्स चलेगा, 5 minus 1 4, 4 minus I की वैल्यू क्या हो चुकी है, 3, 4 minus 3 कितने हो गया, 1, तो 0 ओनली कितने टाइम चलेगा, 1 टाइम, 0 and 1 टाइम. ये तो हो गया पास 3 के लिए. लास्ट पास की बात हम कर रहे हैं, लास्ट पास के लिए कितना चलेगा, ओनली 1 टाइम. ऑलराइट, तो दिस इज द लॉजिक ऑफ बबल सॉर्ट. होप you find it relatively easy after my description, after explaining in my explanation. So this is how bubble sort looks like, and you can complete this logic once you add the declaration and initialization part of these counter variables and array, and later you can print the sorted part also. When you one more time run a loop to print this sorted array, you will find out that the entered elements has been sorted properly. All right, thank you.